Good morning, everyone. Welcome to Test Prep Time Live here at Method Test Prep. Thanks for joining us. My name is Oliver Luisi. I'm the Director of Tutoring here at Method Test Prep. This morning and every day here on our Facebook Live page at 11 a.m. Eastern Time, we're going to be sharing some key strategies and insights about the SAT and the ACT. Some key ideas to look at and look ahead for preparation for these exams. These are really helpful ideas to help to have you focus on the specific topics that are going to be presented and get some insights and shortcuts and strategies that can really save time and help you master these concepts and improve your score on these exams. These are also just good tips and topics to look at for general English and math help in school. And hopefully this can be helpful for you as you take some time now to prepare for these upcoming tests. This morning, I wanted to focus on a really common concept that comes up on both the SAT and the ACT in the math sections. Specifically, we're going to look at, for just a few minutes, quadratics and factoring. Now, many of you that are in Algebra 2 or have completed Algebra 2 are familiar with quadratic equations and factoring, finding the roots of a quadratic. As you can see here, I've outlined a few preliminary concepts just to give us a framework to look at a few sample problems. The standard form of the quadratic generally follows the form ax squared plus bx plus c, with an x squared term, a term with just an x, and then a constant term at the end. When you're presented with a standard quadratic, if it's easily factorable, you generally set it equal to 0. You find two numbers that add to the b term and multiply to the c term. And from your factors, you set those individually equal to 0, or as a shortcut, just reverse the signs inside and you have the roots or your zeros or solutions for this quadratic. What I wanted to focus on today was a slightly different version of the quadratic equation, and that's when you're presented here with a quadratic that does not have a b term. So as we see in this quadratic, we're given the x squared term and then a constant, but there is no b term. In between those two terms, the x squared and the c term, is a subtraction or a minus sign. And this has a specific name. Different teachers call it different things. You may have heard it under different titles. I'm going to call it here the difference of two squares, or as a shortcut you've seen, I've highlighted dots. And the difference of two squares simply means I'm presented with a quadratic equation where the first term and the second term are both perfect squares themselves, separated by subtraction. When I am presented with a quadratic like this, you will quickly find, as you try to come up with the factors, that it will always factor into what are called conjugate pairs. And that's really just a fancy name for opposites. We have x plus 2 and x minus 2 as the factors of x squared minus 4. If I were to distribute or multiply these two factors together, or what's called FOIL, first, outers, inners, and last, we would get x squared plus 2x minus 2x and minus 4. The 2x and the minus 2x cancel out, and we're left with just x squared minus 4. So this is a very helpful property of conjugate pairs or conjugate factors. Now, when they multiply, the x terms disappear, and you're left with just the x squared and the 4. We can use this insight and this shortcut very effectively on many questions on the SAT and ACT math. Let me show you. Here is a question from a recent SAT exam on the non-calculator math section. The question begins by showing us a few small equations. If x plus y equals 13 and x minus y equals 2, what is the value of x squared minus y squared? At first glance, this might seem to be a challenging problem. I have two smaller equations, and then I have a quadratic equation at the end. I see some elements from the first. I see x's and y's, but then they get squared later on. I've got numbers here as well. It may be a little confusing initially whether I need to multiply the two binomial equations, the x plus y and the x minus y, if I need to include the numbers or move the numbers over as a constant. It could be a variety of different approaches you might take. But if you were to actually multiply the two, you would see the same pattern that we just discussed with conjugate pairs. X plus y and x plus y and x minus y would multiply out to, just give me one moment, if I were to multiply the two binomial equations I'm given, you'll see that I end up getting x squared plus a positive xy minus an xy, and then a minus y squared. As we saw earlier, the middle terms cancel out, and I'm only left with x squared minus y squared. And now I can see more obviously the connection between these two smaller binomial equations and this final quadratic equation. So I now know that the product of these two will equal x squared minus y squared. They've already told me that x plus y is 13. They've told me that x minus y is 2. If I multiply those two, I'll have the value for x squared minus y squared, which is 26. And the correct answer here is B. Now, the shortcut that you can save time on is simply to recognize that they've presented you with conjugate pairs, x plus y and x minus y. We know that those will always multiply to dots, or the difference of two squares. And we see that here with x squared minus y squared. If we can recognize that relationship, then this problem becomes very simple, and we always just multiply the values, 13 times 2. We don't even have to necessarily go through this process of foiling if we understand that these two binomial or smaller equations, conjugate pairs, will always multiply together to a quadratic in the form of a difference of two squares. And so the answer here very simply is 26. Now, on this very same test, we encounter a later problem on the grid-in section. You're not given any choices for this question, so you have to come up with the answer yourself. Now, as you read through the problem, I want you to look for similar things that we've seen before. In the equations A equals x minus 4 and B equals x plus 4, A and B are constants. When the product AB is written in the form x squared minus c, where c is a constant, what is the value of c? That's a lot of information in the question. And we're given a few different equations to look at as well. Part of the key on the SAT and ACT is starting to recognize signs and patterns so that things become more familiar. If you were to go to this question without any background information, it could be somewhat confusing and challenging. But if you are used to recognizing certain equations and certain signs, you'll notice we're once again presented with these short binomials, x minus 4 and x plus 4. If you were paying attention earlier, you recognize these are conjugate pairs. So once again, we have x minus a constant and x plus the same constant. We know if we multiply these out, once again, just as we've been doing, we will discover that same property. The x times x gives us x squared. Then we get a negative 4x, a positive 4x, And negative 4 times positive 4 will give us a final constant here of negative 16. As we discussed earlier, the x factors cancel out. Negative 4x and plus 4x equals 0. And we're left only with x squared minus 16. In the question, they said if you multiply a and b, we know that x minus 4 equals a, and we know that x plus 4 equals b, some constant we're not given. But we know that these two numbers, whatever they are, will multiply and then be written in the form x squared minus c. Well, that's what we've produced by foiling the two conjugate pairs. We've made it in the form now, x squared minus 16, you will recognize once again is a dots form, or a difference of two squares form of the quadratic. And we now know the product of a and b is x squared minus 16. They're asking for the value of c. An important reminder here, everyone, as you work through the question, always come back and revisit the final question. Make sure you know what your ultimate goal is in a math question. Don't spend a bunch of time working on something that's not getting you towards the answer. What we needed here was simply the value of c. And in this case, the value of c will be that constant in our new quadratic. And the answer to this question on the grid-in section is 16. Once again, using the property of conjugate pairs to create a difference of two squares, and we find the constant at the end for the answer. All right, I just want to look at one more question because surprisingly, this is later on in a similar section of math. And it presents what at first glance appears to be a very similar concept once again. Now, this question also involves another very important idea or strategy within the SAT and ACT, and even more so on the SAT, this tends to come up. Yesterday, my colleague Elliot discussed translating words into math. This seems like maybe a simple idea, but it can be pretty challenging. Turning the words of a math problem into a math equation. Now, your math brain is very smart and can handle a lot of math computations and concepts, but it's not very good at English. So you have to give it a moment to slow down and take each word from the problem, translating that into an equation. Watch how I do that here. I'm going to go into the question. I'll read it through once first. The sum of two different numbers, x and y, is 70. And the difference when the smaller number is subtracted from the larger number is 30. What is the value of x, y? It might seem at first glance that you don't really have enough information here. They haven't told us a tremendous amount about x and y, only what their sum or difference might be. But let's see if we can translate these words into an equation. The sum, that'll be a plus sign. Notice how slowly I'm going to let my math brain catch up to the English. The sum of two different numbers, x and y. Okay, so I'm summing two numbers, x and y, that is, in math is always an equal sign, 70. So I have x plus y equals 70, another binomial. And the difference, okay, now I have a subtraction sign. When the smaller number is subtracted from the larger number is 30. So the smaller number, in this case, they don't indicate which is bigger or smaller. So I'm just going to assume or try out first y being the smaller number, and that's subtracted from the larger number. We'll call that x. That is or equals 30. Okay. Now, at first glance, especially if you've just completed the previous problems, you might recognize these are also conjugate pairs, x plus y and x minus y. And of course, if we multiplied these two expressions together or FOILed them, we would get x squared minus y squared, and we would find out that that equals 70 times 30. However, we have to be careful. This question doesn't ask for the product of these two equations. It asks for the product of just x and y, or the value of x, y. So therefore, I quickly discover this is not quite exactly like the previous questions. Here, I need to actually find out the values of x and y. Now, how do I do that given two different equations? Well, when you're given two what are line equations or linear equations here, and I need to solve for x or y, this, in fact, is what's called a system of equations. I have two different equations here, and I need to find where they intersect on a graph, but algebraically, it means what is the coordinate x and y that solves both of these equations. For a system of equations, I generally want to eliminate one of these variables and solve for the other one. I can usually use the process of elimination or substitution. In this case, I'm going to do elimination because I can quickly see if I add or combine these two equations together, I'll be able to quickly eliminate the y's. So if I add the x's, I get two x's, plus y minus y, those cancel out, and I'm left with 2x equals 70 plus 30, or 100. Dividing both sides by 2, I can quickly see that x equals 50. Now that's not my answer because I also need to find out what y is. Okay, take your x value and now plug this back in to either of the equations. If you put it into the first one, you'll get x plus y equals 70. We know that x is 50, plus y equals 70. Subtract 50 from both sides, and you'll quickly find that y equals 20. If you were to put it into the other equation, you would find the same. 50 minus y equals 30. Therefore, negative y equals negative 20, or y equals 20. So now we know that x is 50. We know y is 20. And they're asking for x times y. 50 times 20 is 1,000. And we've arrived at our answer. So this was just a quick counterexample of how the previous idea of conjugate pairs, which comes up very often, can serve as a quick shortcut or insight on otherwise more challenging looking problems. Just be careful if you come across them in another problem. Make sure you're focused once again on your goal or the actual question. It wanted here the value of x times y, not the value of x plus y times x minus y. Okay? So be on the lookout for these conjugate pairs or opposite pairs that foil together to create a dots or difference of two squares. Those conjugate pairs can be very helpful as shortcuts on a lot of math problems on both the SAT and the ACT. So I hope this little lesson was helpful and can really translate into points immediately on the SAT or ACT math sections. As I said, every day we're going to be here live at 11 a.m. Eastern time to present to you a couple of key ideas and strategies that this is really valuable. I mean, this translates into points immediately on the SAT and ACT and can really boost that score, translated into acceptance at universities, as well as potential funding and scholarship funding depending on your score. So every point counts on these tests. I do want to note a couple of final things. We have an excellent online self-paced program. It's a full course for the SAT, a full course for the ACT, filled with strategies, insights, examples, just as I showed you, lessons, quizzes, videos, explanations taking you through all these strategies, as well as full-length exams that you can practice and see where your score's at. Normally, this subscription would be $199 for the program. We're offering 50% off today for anyone attending live. You can use the code FUTURE. Just go to the URL at the bottom or visit our website. You can enter this code in at checkout and get this program, an excellent educational tool, especially at this time where you may be working primarily from home, a tool that you can use for the SAT, ACT, and general help on math and English concepts for school. And this is something you can use all year long or throughout your test prep. In addition, we have live full-length online classes, some starting tomorrow, and there's others coming up as well. Just go to our website, methodtestprep.com/classes. We have a power class starting tomorrow, March 21st. And reach out with any questions you have. We have an excellent blog keeping you up to date on changes, updates to the SAT and ACT, general prep and good practices, general information on college readiness and college application. In addition, we do free consultations all day, every day for parents across the country. We'll sit and talk with you 30 minutes, 40 minutes, answer any questions you have, provide you some background information on the SAT and ACT, and especially during this somewhat transition time or where things are up in the air, we know that the SAT and the ACT have been rescheduled for June in most cases across the country. You may be concerned with how to map out the next few weeks and months leading up to those exams now that your test prep schedule has maybe slightly shifted. Give us a call. We'll talk to you. It's no cost. We love to share this information and provide parents and students with as much tools and as much knowledge as possible about these exams, and could at least eliminate some of the unknowns heading into the next few weeks and help you make the most of this time as you prepare for these exams that will come up sooner than you think. I hope, again, this was helpful. Again, my name is Oliver. Please reach out if you have any questions. I'm going to take a quick moment just to see if there is any chat here. Thanks again for your time. Hope everyone stays safe and healthy out there. And we'll talk to you soon. This is great. Great feedback. Thank you, Lisa. Great to hear that. You know, I've done a lot of English and math for many years, but finally, you know, seeing these insights on these tests can be really critical. It doesn't even necessitate that you're taking, you know, hours and hours of Algebra 2. Just to see these small insights can be really effective on the test. And this is how the smart student prepares. They're efficient by focusing on these key ideas that can translate into a lot of points on a lot of questions on the test. Great. Well, good luck on the exams. Good luck during this time, and reach out again. The information I've put up here, 1-877-871-PREP. Happy to answer any questions you have and just discuss general test prep with you. Until the next live test prep time, I believe is going to be Monday. We'll see you then, and have a good day.